Herzlich willkommen bei mathepunk. The solution of the radical equation square root of n minus square root of n plus x equals x. We are trying to find real solutions of this radical equation. In the first step, we square both sides of the equation and we obtain n minus equals x squared. Here on this side, this side is non-negative. It's greater or equal 0. This means that x must be greater or equal 0. After squaring both sides of the equation, we rearrange terms and obtain n minus x squared equals this square root. The right-hand side of this equation is non-negative. This means that x is between minus square root n and square root n. But x can not be negative. So we have the following. So this is the range of x. We square once more both sides of this equation now, and we obtain this equation of fourth order. We put all terms on one side. This gives us x to the fourth power minus 2nx squared minus x plus n squared minus n equals 0. Now it can be shown that this term on the left-hand side can be represented by a product of two quadratic terms as follows: x squared minus x, and then x squared plus x minus n plus 1 equals 0. So since this product equals 0, we can obtain solutions by setting each of the factors equal to 0. So first we have and furthermore okay, now this gives us the following. And this gives us Okay. Now I will list these 4 solutions. x1, x2, x3 and x4 are solutions to this quartic equation. However, x2 is less than 0 and also x4 is less than 0. Furthermore, x1 is greater than square root of n. So x1, x2 and x4 have to be discarded. They are not solutions of the original radical equation. And what's left is x3. And indeed, if these numbers which you obtain with this formula, if they are inserted into the original equation, they turn out to be indeed solutions of this equation. So this is obtained.